this is a class we're making, a rectangle, which consists of one point representing the upper left corner of the rectangle and one dimension representing the width and height. The point dimension instructions have already been declared in the header file. We're going to place our definition in P1H and our implementation in P1.cpp. So I've already unzipped it, and what I'm going to do is I am simply going to start with the class definition for rectangle. So class rectangle, and I'm going to put in my two sections, my public section, my interface, my private section, and I'm going to have a point location and a dimension size. So that was two data members, location and size, their type of point, dimension. And I am going to go ahead and show you what this looks like when I test it right now, so you can see the testing. The testing is relatively extensive. It takes a little while, so you're not going to want to test all the time. But of course you can test as often as you like. I just want you to see what it looks like before we go ahead and complete the solution for this. So you will have three parts. One part is the class definition that is testing the header file. You can see the various things I'm checking, the definitions for the accessors, the mutators, the overloaded operator, and the non-member function. The second part is also syntax. This will be essentially the stub functions. In other words, in the implementation CPP file, do these things compile? We're not checking to see if they work correctly. We're checking to see if they have the correct prototypes, the correct input and output. They're correctly implemented. And finally, the very last part is going to check some of the correctness of the code. So you will want to make sure that we do this part 1 first. That's about 30%. Part 2 is about another 30%. And the last part is the last 30%, checking to make sure it all works correctly. So let's go ahead and look at what goes into the public interface. I'm going to increase the size of this a little bit more. And you can see that we are going to have a default constructor, and we're going to have an overloaded constructor. We're going to have some accessors. And so what I'm going to do is I'm just going to copy these things right here. I'm going to take them over to my CPP file. And I'm going to put them right here. And then we will okay, so the first thing we're going to do is I'll erase them. So the first thing we're going to do is the default constructor. That is the same name as the class. No arguments. That's the default constructor. A working constructor that takes 4 doubles, x, y, width, and height. So rectangle, double x, double y, double width, double height. Okay, we've got the second one. Okay, now let's do some accessors. So double get area, and remember accessors do not change the object, so they're marked as const. Double get width, double get height, double get x, and double get y. So there are our accessors. Now we have 2 mutators, set location and set size. So void set location double X, double Y, and void set size, double width, and double height. And finally, we have an overloaded operator. Now, when you do this and you test it, if one of them causes it not to compile, you just comment it out. Make sure that your code compiles. Okay, so this is going to return a rectangle object. Operator plus. And it's going to take, that's the right-hand side, and it also is not going to modify the object. And then finally, one non-member function that's going to be down here. It's going to be named intersection. It takes two rectangle parameters, returns a rectangle. Okay, so this is not a member function, so it's going to be rectangle, that's the return type, intersection, it's the name of the method. These are input parameters, so const rectangle, ref, left-hand side, and const. And since it is not a member function, it's not a method, it doesn't have const at the end of it. Okay, so let's go run our second set of tests here and see if we've got, last time we had 7.5%. Now that we've written the header file, let's see what that goes up to. Okay, so we want to make sure all these are pluses. We do not have any minuses inside here, so that's perfectly fine. Nothing is implemented yet, and we have about 35%. Okay, now let's implement this. Again, this part of the test is just going to make sure that we have the syntax correct. And so we're going to copy all of our member functions to our CPP file. And we're going to copy our free function down here, our non-member function, to our CPP file. We're going to put rectangle colon colon in front of each of the member functions. So there, 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 and there. And I'm going to move these over all to the left. Now we're going to stub them out. Stubbing them out simply means removing the semicolon, making sure that the return type is correct. So for all of these, I'm just going to return 0.0. I know we could figure out what they're going to return right now, but again, I'm trying to do this in order, stubbing them out. These are void, so they don't need to have anything happen to them. And this is going to return a rectangle object. And this one is also going to return a rectangle object. Okay, so for part 2 here, again, I'm not looking at How these work at all? I'm just the syntax. So step 1, copy all the prototypes over here. Step 2, fully qualify the member functions. Do not qualify the intersection function. This doesn't say rectangle : : However, we do need to fully qualify the operator. So that should be correct for that. Step 3, remove the semicolons, put bodies on them, and return some dummy value. So now we have stubs. Now I can test that. Before I was about 35%. Now we're looking to see that the second part tests correctly. So here's the first part. All of these should still be correct. Second part should all be correct. Now I have a -1 here on that. That may just be a timing error. All of these should be, of course, failing. So we should be up to about another 30 to 35%, 67%. That looks correct. We'll see next time if this works. Okay. Now we need to make this work. So the default constructor up here needs to set both the location and the size to 0. And so we can do that. The long way. So I can say location.x equals 0, location.y equals 0, size.width equals 0, size.height equals 0. There are some other ways we could do it, but this is just the most straightforward way. So location.x equals x, location .y equals y, size.width equals width, and size.height equals height. The accessors are also equally quick. Get width is simply going to return size.width, and get height is going to return size.height. And get x is going to return location.x, and this is going to return location.y. And this up here is going to return get width times get height. Okay, we can call the function. Set location is simply going to say location x equals x, location y equals y. And set size is going to say size.width equals width, and size.height equals height. And those are kind of all the easy ones. Let's see what happens if we don't do anything else and we just try and go with the easy ones here. Takes a while for this to go. Okay. Okay, so all of these we got implemented. So all of the syntax is okay. This is correct for the constructor. This is correct. Set size, set location, and get area. So now we just have 2 more to go, and we're roughly at 90%. Okay, I'm back. It looks like we have all of the functions working okay, except for the overloaded operator and the intersection non-member function. So that's pretty good. Let's go and look at those right now. So here's our overloaded operator. Our overloaded operator is going to construct the union of 2 rectangles. And the union is basically the a rectangle that will enclose the two other ones. So we want to find the left part. So double left. And the left part is going to be the furthest to the left of either get X or right-hand side get X. So it'll be the smallest one. And we can do either a conditional operator, but it's easier to do just the min built-in function. So min get X and right-hand side get X. And the same thing for the top is going to be the smallest of get Y and right-hand side get Y. Now the right and the bottom are going to be the largest of so double right is the maximum of get X plus get width, and right-hand side get X plus right-hand side get width. And the bottom is going to be similar. It's max get Y plus get height, and right-hand side get Y plus right-hand side get height. Okay, so we've got the left, the top, and the right and the bottom. And so basically what we're going to do is construct a rectangle of that. Left is going to be X, top is going to be Y. The width is going to be right minus left, and the bottom is going to be, the height is going to be bottom minus top. Okay, so that should give us the union. That looks like it should work pretty well. The intersection is going to be really kind of similar. Basically, I'm going to copy these same things over here. But for X and Y, we want max and max. And this we want the minimum and the minimum. And if right is greater than left and bottom is greater than top, we're going to return a rectangle that is at left, top, right minus left, and bottom minus top. Otherwise, we're going to return the default rectangle. Okay, that should pretty much do it. Let's go ahead and look at this last test and make sure it works correctly. Okay, so that's okay. We have some kind of syntax error somewhere. And so I did not do this, which I should have. It would save some time. I did not compile first. Oh, yeah, good. So this is left hand. So this is not a member function. So it doesn't have a get x and get y. I have to remember that I have two objects. And let's compile that first rather than just, okay, so now it compiles, so now we can go and run the test program. Make sure you use the compile thing, because the compile thing will be very, very fast, whereas running the checking program is relatively slow. And it doesn't tell you what's the matter, whereas compile will tell you exactly what the problem is. Okay, so again, the definition, now all of these syntax is correct. Plus, 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 so 100%.